Okay, my name is Miranda Waldron. My job in the Centre for Imaging and Analysis is to work a scanning electron microscope. It gets a higher resolution than a light microscope, so you're looking at smaller things than you can see in a light microscope. It works in a vacuum, so your samples have to be small and dry and they have to be conductive. Then you put them into a vacuum chamber and you turn on an electron beam. It sort of interacts in the same way as reflected light. This is an infrared picture of what is inside the microscope. So this is the vacuum. This is the holder that takes those little stubs that we've just seen, those little aluminium discs. And this is the column. The electrons come out of the column and they interact with your sample and they're collected by this detector. My background is biological, so I like the biological stuff, like the sponges and insects and that sort of thing. But the demand for the microscope comes mainly from engineering. Things like looking at catalysts, looking at pieces of metal, composition and what they do under different conditions. Quite a lot of chemistry, and we get a little bit of the biological sciences. It's a study actually run by the Department of Environmental Affairs, and they're trying to just classify the sponges around the coast of South Africa. So they go and collect the sponges and they just bring loads and loads of different samples. The sponge itself is big, so you basically have to break that sponge up into those individual things. Like they put it in a little water bath and subject that to ultrasound, and that breaks the whole thing up. Then it's cleaned, you take away the organic matter. So that basically what's left is calcium skeleton. So one big sponge is made up of millions of those tiny little spicules. They are probably about between 2 and 5 microns. So you can't see them with the naked eye. All the pictures are black and white. And I'm just interested in taking the nice ones and making them colour, just because I like doing that sort of thing. That little ball of flowers, it's just such a cool sort of natural thing. That's nature just done that. So I just think it's really, really cool. And then they just happen to be arranged around the spiky one. It was just luck that that's how it ended up. That's 2 different species. So it just happens that there's 2 species together when the sample was collected. I'd never seen anything like that before. So when I first saw it, I just couldn't believe that nature could do that.